Hi guys. A few of you missed the chapter 1 and the chapter 2 review in class with all the stuff that's been going on. So I just wanted to work out the problems for you. Also, some of you asked me to make a video, so here it goes. This is the chapter 1 review problems. Let's start. Let me see. Is my camera a little crooked? I think that's better. Okay, so the first question asks to state the domain of the function using interval notation. Remember with interval notation and with the domain, okay? So number one, all right, the denominator cannot equal 0, okay? Not that x can't be 0, it's just it cannot have a value of x that would make it equal 0. By the way, if you hear squeaking in the back, that's my dishwasher. I don't know why it makes that sound. I'm assuming it's ready to die, but we're hoping not. Anyway, so what will make this denominator equal 0? Well, I'll set it equal to 0 and find out. And I realize that when x is 4, the denominator is not going to be defined. I can't have x being 4. All right? So if I think about it on terms of a number line, all right, if x is 4, I don't want that. I want all the numbers in front. I want all the numbers here. However, this problem also has a radical. Remember, the second restriction we have in our domains is that even radicals, okay, have to be greater than or equal to 0, meaning they have to be positive. We can't have a negative number. All right, so it's very simple. It's just x, so x has to be greater than or equal to 0. So that means x cannot be 4, but it has to be greater than or equal to 0. So I kind of have to stop my domain here and say this. So now the domain, if I looked at this number line and now I want to put in interval notation, I start at 0. Okay, it includes 0 because I could have a 0 there. The square root of 0 is 0. All right, it goes all the way to 4. However, 4 is not part of my domain, so I have to end my interval notation, jump up over that 4, and continue on to positive infinity. Okay, let's look at question number 2. Question number 2, we're going to be using this graph, so I'm probably going to write on here. So again, state the domain using interval notation. So the domain starts this way, so it starts at negative infinity, but you see that negative 3 has a hole. If I asked you, when x is negative 3, what's y? There is no answer. So my domain starts at negative infinity, it goes to negative 3, and then it jumps over it, because negative 3 is not part of the answer. It continues up into, if you see, this is an asymptote at 1. See how the graph now starts to level off? It doesn't cross there, and it comes back this way. So we have an asymptote at 0. We'll jump over that asymptote. We'll continue on. Now be careful here with this hole, where this hole and this hole are different. Whereas this hole, if I said to you, when x is negative 3, what's y? There is no answer. But over here, if I say to you, when x is 3, what's y? You could say y is 4. There is an answer. It's just not here. It's there. So from 0 all the way to positive infinity, it just continues. So that would be my domain. My range, remember, goes bottom to top. I'm coming from negative infinity. Even though I have a hole here at negative 1, negative 1 is represented at this part of the graph, so I don't have to worry about it. As I continue on my y, I have a hole here, but I'd have an answer here. And even though this part of the graph stops, the graph continues on. So my range for this is going to be from negative infinity to positive infinity. Okay, again, when x is negative 3, we kind of did that. We write it does not exist. Now, remember what we did here. There is no existing of an answer here. And they want you now to evaluate, well, if you approach negative 3 from the negative sign, so that means coming in from this direction, what y value are you starting to go to? And I'm going to 1. If I approach negative 3 from the positive side, I am again going to the y value of 1. So if we're approaching both these numbers, you would think that this would be 1, but since this does not exist, that we know the discontinuity is a hole. Same thing over here, 3. When x is 3, y is 4. Now look what happens. As we approach that value of 3 for the x from the left, my y value is going to -1. But as we approach it from the right side, which is what this is asking, my y value is 4. See how it's disconnected? Okay, that's why this is jump discontinuity. Okay, because we're coming at the value at two different ends. Now, describe end behavior. End behavior wants to know what y value is this part of the graph approaching. We write it in limit notation. The limit as x approaches -infinity, that's just a fancy schmancy way of saying going to the left, your graph approaches 0. See how this is starting to get to 0. It's never going to get there. It's approaching. It doesn't say what does it land on. It's trying to get there. It's not going to happen. As we go to the right, look what's happening here at the end behavior. The limit as x approaches positive infinity, which means to the right, your graph, which is f of x, is going down towards -infinity. Okay, so number 7 is asking you to determine if h of x equals 3 over x squared plus 5x if it's an even function, an odd function, or if it's neither. What we did is we replaced this with a -x. We substituted -x into the problem and we simplified it. So it's 3 over now -x squared plus 5 times -x. When I simplify that, if I take a -x and I square it, a negative times a negative is a positive. If I take a -x and I multiply it by a +5, I get a -5x. Now, to be an even function, for every x in the domain, when you substitute in -x, you're going to get the same equation, meaning if I were to plug this in and I would get the same exact equation as the beginning, it would be even. This is the same, but this goes from positive to negative, so it's not even. Odd would mean that everything would be the opposite. This is the opposite, but this isn't, so it's not odd. This is neither. That's how you do those. You plug in -x and you simplify it. Okay, let's see what else. Okay, the continuity test. All right, so here they put in, basically in a chart form, what's going on in the graph form, okay? And they want you to determine what kind of discontinuity is here. This is saying you're going towards -2 from the left side, and your value right before -2, like right before here, you're at -1,000. But on the right side, okay, you're at positive 1,000. It's almost like what's going on here. If I said in this graph, if we're approaching 0 from the left, I'm going towards positive infinity. If I'm approaching it from the right, I'm going to -infinity. So since these two numbers are so far apart, this is an infinite discontinuity. See, when they were very close together, basically the same number, and that one didn't exist, it was a hole. And when they were close, you could jump back and forth. You ain't jumping this. Okay. So if we want to name and classify the extrema, that just means the maximum and minimum points. Remember, we had a few types of maxima mins. We had an absolute max. We have an absolute min. We have what's called, move this up a little bit, a relative max and a relative min. Now, absolute means the highest point. If you look, this graph doesn't have an absolute max because this is a high point, but it's not the absolute highest point. This graph continues up to positive infinity. So we don't have an absolute max. We have a relative max when x is at -1. So when x is at -1, I have a max. I have not relative mins because these are the absolute lowest. So it's not a relative min, it's an absolute min. And your graphs can have both, they could have neither. And we have it at when x is -3 and when x is 1. Oh, Oh, some might think got dark. I don't know if it happened on your video. Okay. Describe the end behavior using limit notation. As x approaches negative infinity, this goes up. As x approaches positive infinity, this goes up. Okay, so they're both going to approach positive infinity. State the intervals for which the function is increasing. Guys, there were 3 things you had to remember here. Just draw arrows, okay? You have to remember to, number 1, only use your x values. Remember, I described this as I'm walking through Manhattan and I want to find the address of the tallest building. I'm not asking you for how tall the building is. I'm asking you for where it is located, okay? So I can say that this graph is, let's see, I need more paper here. So the first thing, increasing. So this graph is increasing from here to here. But we want the interval. We don't want to know low point, high point. We want to know that's increasing from -3 to -1. You always use the x. You always go left to right. And you always use soft brackets. And it's increasing from 1 to infinity. It is decreasing from negative infinity to that 3. Okay, remember, we don't want the y. We only want the x's. And it is decreasing from 1 to 1. And it's not constant anywhere. The constant level off. Okay, my domain here is from negative infinity to positive infinity. My range, however, the lowest point is -2. And actually, it's a hard bracket. Sorry about that. -2, and it goes to positive infinity. Okay, let's see what we have going on this other side. Okay, so the formula for distance traveled by falling objects in the moon is d of time equals 2.7 t squared. And they want you to find the average rate of change on the interval of 1 to 3. This is basically a slope question. Okay, you're going to use that slope formula, all right? But they only give you x values. They didn't give you y values. So what you need to do, you need to plug in when x is 1, what is y, by plugging it into the equation. 1 squared is 1 times that is 2.7. And then you have to plug in 3. 3 squared is 9, so it's 2.7. You think I would have sat down with a calculator? That would have made sense. 63, 6, 18, 24. So this is 24.3. And then we're going to plug that into the slope formula. So slope is y2, 24.3, minus y1 over, I don't know why I put parentheses there, 3 minus 1. So this is, the denominator is 2, and again, don't know why I didn't bring a calculator. 6, 3, 1. I think that's right. I did that quickly in my head, and then you would just divide it by 2. Okay, you guys could do the math. I just wanted to show you how to set it up. All right, you should know your parent functions, guys. We spend a lot of time on parent functions. Okay, you know that this is the swoosh. Okay, this swoosh got reflected over the x, so that means it's going this way now, and it got shifted down 3. So instead of starting here and going this way, it's going to move down 1, 2, 3. And instead of following the pattern of going up 1 over 1, it's going to go down 1 over 1, and then over 1, 2, 3, down 1. And it's going to continue in that pattern. And remember, there was a way to check it. All right, look at this point. This point is 4, -5. I could substitute that into here. Let's see, if x is 4, if the square root of 4 is 2, so now -2 and a -3 is a -5, so it checks. I didn't do step functions, so don't worry about that one. Okay. Compressed horizontally. Remember, horizontally was the horror show. That was in the house, and it was always the opposite. So we're going to put a factor of 1/3, means it's going to be 3x squared. It goes in the house, and it's a flip. So that would be your g of x function. What transformations happened here? Well, up 3, everybody loves that one. Positive 8 means to the left 8, and negative is reflect over x. Remember, if it's in the house, it's why is there a negative in my house? Okay. Let's quickly go through these functions. I didn't want this video to be so long, and it's up to 15 minutes already. Well, it is what it is. What can I tell you? All right. So we have f of x equals x plus 2. Ladies and gentlemen, I expect you to get these right on your final. This is an Algebra 2 concept, okay? This should be, you're adding the two functions together. You need to be able to combine like terms. X plus 2 plus x squared minus x minus 6 is x squared. The x's cancel out, negative 4. That's your answer, guys. Don't factor it, don't do anything. That's your answer. 22, g minus f. Be careful here because subtraction, you're going to have to remember to distribute the negative. Make sure you put in the right order. It's the g function first minus parentheses the f function. Distribute that. X squared minus x minus 6 minus x minus 2. So that's going to be x squared minus 2x minus 8. That's it. This means multiply. This is a composition. Know the difference. So f times g. So that's going to be x plus 2 times x squared minus x minus 6. Distribute. So I get x cubed minus x squared minus 6x. Distribute. So that's plus 2x squared minus 2x minus 12. X cubed plus x squared. And I like to do it this way. You could write it horizontally. However you want to do it. I just like keeping this in order. It's just multiplication, guys. All right. Let's look at, this says g over f. So the g function is x squared minus x minus 6 over x plus 2. Let's see if I could factor anything. This is going to be x minus 3, x plus 2 over x plus 2. So this would cancel out. The answer would be x minus 3. And remember, when I have this in the denominator, I have to say that x cannot be negative 2. I need to state that because that would make it undefined. All right, now let's do f of g and g of f. I got to turn, I'm running out of papers. Hold on a second. All right, so if you remember when I taught you f of g, oh, this is a 5. This one's actually easier than that one, I feel. That means you're going to take 5, put it into the g function, get an answer, take that, and then put that into the f function. So if I take 5 and I put into the g function, I now have 5 squared minus 5 minus 6, 25 minus 5 minus 6, 20 minus 6 is 14, and I'm going to put that into the f function, which is just x plus 2, so that the answer is 16. All right. G of f of x. I'm doing the same thing basically, okay? If you remember, I told you rewrite it and then replace it. The x function, the f function is really f plus 2, and then put this into the g function wherever there's an x. It's the same thing you did here, only instead of doing it with the number, you're doing it with the function. So g says x squared, so it's x plus 2 squared minus x plus 2 minus 6. Please, guys, for the love of everything that I taught you this year, know that this is a FOIL. This is not x squared plus 4. This is x squared plus 4x plus 4. Distribute that, minus x minus 2 minus 6. X squared plus 3x, a positive 4 minus 2 is 2, 2 minus 6 is minus 4. And that's what I have for that one. Okay, let's see what we have here. Write the equation for this, okay? This is an absolute value function that got reflected over the x. It seems to be shifted 1, 2, 3 up and over 1, down 1, 2, 3. All right, so it's going to be g of x equals negative. All right, I'll be honest with you. I would not move it to make you write it like this, but let's just see. Since it got compressed, it went over 1, 3. So the vertical got by 3. So let's do 3 here. Sorry about that. And it's just going to be x, and it's up 3. Okay, because you went over 1 still, and then down 3, over 1, down 3, over 1, down 3. Okay, just that's a negative in front of the 3 because it was shifted over the x-axis. Is this function even, odd, or neither? Okay, since you can split it down the middle, okay, it's going to be an even function. Odd would be, remember, if we rotated it 180 degrees, you'd have the same thing, but this is symmetrical on the x-axis. It's not symmetrical on the y, not the x. Apply the horizontal line test to determine if the inverse has, whether its inverse is a function. Oh my God, you can tell I'm getting late. Since it hits it twice, the inverse is not. And they want us to write an inverse for that. Let's do that real quick, and then we'll be done with chapter 1, I think. So to do inverse, remember we switch x and y and solve for y. So 5 over x plus 4. Looks like a y. Okay, switch x and y. So I have x equals 5 over y plus 4. Let's bring the 4 to that side. X minus 4 equals 5 over y. Multiply both sides by y. So now I have y times x minus 4. I'm sorry, I'm getting off the screen. Equals 5, because that cancels out. And I want to get that y alone, so I'll divide by x minus 4. It's just algebra, guys. Y equals 5 over x minus 4, but you should use the inverse notation. Equals, sorry again, 5 over x minus 4. Okay, I just want to check to make sure there were no other questions for chapter 1. Okay, basically it's the transformations. We know that this is up, this is down, this is a reflection over the x. This is a vertical expansion of c if it's greater than 1, 1 over c if it's between, if it's the fraction. This is plus, so we're going to move it to the left. This is to the right because it's the opposite. These are horizontal. This is a reflection over the y. This is a horizontal compression. When it's greater than 1, it becomes the fraction. And when it's the fraction, it becomes the whole number. Okay? All right, I'll make a review packet on the chapter 2 after, and I'll load that up. I hope that was helpful.